Hi everyone, welcome to another episode of Edge Functions at Supabase. My name's Greg Richardson. I'm a guest speaker here today to talk to you about streaming with Supabase Edge Functions. So first off, what do I mean by streaming? If we take a look at the Dino blog, they have a really nice article here on web streams at the Edge, and they go over a couple different streaming strategies from Dino, which is the runtime used by Supabase Edge Functions. Here they talk about how you can actually proxy HTTP streams through Edge Functions. So essentially, if from your Edge function you need to make a fetch request to another API, you could do that here and actually stream that response directly back to your client without buffering any data. This can be extremely handy in some situations. Down here, there's another type of stream called server-sent events. Server-sent events work alongside the event source API available in the browser. And this is essentially a spec that has defined a nice way to stream events from the server to client. Now, worth noting with server-sent events, they are unidirectional, meaning the stream is only from server to client. Essentially, your client would make an initial fetch request to the server, and the server, in this case our Edge function, would respond with this special content type, an event stream, where it could continuously send data back to the client. Server sent events is what we're going to focus on today in this video. And then worth pointing out, there's one more common type of streaming you most likely are familiar with, known as WebSockets. Unlike server sent events, WebSockets are actually bidirectional. So not only can the server stream data to the client, but the client can also stream more data back to the server. Dino functions do support WebSockets as well, but there's a little bit more work involved with that. So we'll leave that for another time. All right, let's go back to our VS Code editor here and let's get our project set up. Of course, to initialize a Supabase project, as always, we'll do a Supabase init in a terminal. This will create a Supabase subfolder for our local project. Next, in order to create our local Edge function here, we can run Supabase functions new, followed by the name of our function. Let's call this one stream. And then as you can see on the left-hand side here, we have our brand new function. And of course, just like we have in the past, we're going to open the command palette and run Dino Initialise workspace configuration, which will tell VS Code that this project is a Dino project. We're going to enable linting and not enable unstable APIs. If you didn't have that command available, you just need to come over to your extensions and install the official Dino extension. Okay, so what are we going to stream today? Probably one of the best examples of a stream in action is the example we were just looking at on Dino's website, where we can actually have a timer interval that will send back a message periodically. Let's prove our understanding of this by trying to get to work ourselves. We'll come back over here to the documentation under server sent events and go ahead and just copy this code over into our VS Code. We can go ahead and replace this. And we're just getting this warning because we don't actually need this function to be async right now. We have nothing awaiting, so we can probably just get rid of async for now in order to make VS Code happy. So let's go through this line by line to understand what's exactly happening here. And probably the best way to start with this is actually to start at the bottom and then work our way backwards. So at the very end here, you can see we're returning a response. In Dino, you return a response by creating a new instance of this response class. The first parameter of the response would be the response body. In this case, this is actually going to be a readable stream, which we're going to touch on in a second. And then the second parameter is a couple different options here. We got headers. There's also a status you could set here, as well as the status text. And worth noting, when we're doing server sent events, we do need to set the content type to text/event stream. That's part of the spec. So let's work our way back up here and take a look at our body. So as I briefly mentioned earlier, our body is actually a readable stream. What does that mean? Well, instead of sending, let's say, one big string of something, quite often a string of JSON we'd send back, instead of having that available all at once that we'd send in one big chunk, a stream actually will allow us to continuously send more data through that response body over time. And it actually doesn't require us to have all that information available up front. This is exactly how streams work. So with a Dino readable stream, the format looks like this. When you create a new instance of it, the first parameter expects an object containing a couple things. First, we have this start method, which is a handler that will be called when the readable stream, as you'd expect, first gets started. This handler passes through a parameter called controller, which, as you can see here, is a readable stream default controller. Essentially, what a controller allows you to do is on queue or send new messages through the stream. Now, quick aside, worth noting that readable streams aren't specific to server sent events or even HTTP requests at all. Readable streams in Dino are much more generic and can be used for many different purposes. It just so happens that readable streams integrate perfectly with HTTP responses. That's no accident, of course. Okay, and then second here, we have a handler for cancel. This handler will get called anytime a cancel operation is triggered on the stream. So in this case, let's say our HTTP response got canceled. This method would get called then. So what's actually happening here? Well, in this example, we have a classic set interval. This set interval will be called every 1000 milliseconds or 1 second. And we're essentially on queuing a new message to the readable stream every second. And then if the stream were to get canceled, then we go ahead and clear that interval. Now, finally, let's work our way back up to the top here and we take a look at this message that we're on queuing. When it comes to server sent events, a server sent event is actually a text-based protocol and does in fact require this format here. So you see we have data :space followed by the message that we want to send. And then afterwards, we have 2 new lines afterwards. So if you were to go look at the server sent event spec, they will talk about how every new message that you send will need to follow this format. So if we were to actually run this function, what should we expect to see? Well, in theory, when we call this, we will have a new set interval that starts up. And after the first second, we should start seeing a hello message followed by 2 new lines prefixed with data : and our request should just continue to send that back through the body every second. Let's try it out. Now, just a quick reminder, in order to test out our Supabase function locally, we'll need to first spin up our local Supabase stack. To do that, we run Supabase start, and your local Supabase stack does use Docker containers under the hood, so you will need Docker installed to run this. Okay, now that that's started, we can go ahead and serve our Edge function locally. Let's go ahead and do that by running Supabase functions serve, followed by the name of the function. We called ours stream, and now our local server is running and waiting for requests. So one of the easiest ways we can test this out is by using the CLI command curl. And when we created our new Edge function, we actually get a sample curl command down here at the bottom. Let's just go ahead and uncomment that, copy it to our clipboard, comment that back out, and back in our VS Code terminal, we'll open up a new terminal tab here. And let's go ahead and paste that curl command. Once again, when we run this, we should expect to get our response headers right away, but then the body itself will be streamed and we should expect a new message every second. Let's see what happens. So there's our headers. And perfect. Every 1 second, we're getting a data hello message. We just built our first server sent event stream. So from here, the sky's the limit. You can use this tool to stream whatever you want. I'll let you use your imagination for some great use cases for this. Someone that come off the top of my head is perhaps streaming progress. You know, if your backend has to do a long operation, you could stream back progress to the front end to keep the user up to date so they know where you're at with the progress. Or perhaps your Edge function is calling another API, and that API takes a long time to respond. And in fact, one of the most practical use cases I can think of today that we might want to do that with is OpenAI's completion model. I'm sure many of you have heard of ChatGPT, and you may have noticed that when you ask it a question, it will respond not all at once, but it actually will stream each word one by one as they become available. And it turns out that OpenAI uses this exact same method, server sent events, in order to accomplish that completion streaming. So now that we know how server sent events work within Supabase Edge functions, it actually should be pretty straightforward for us if we wanted to actually integrate with OpenAI's completion model. And instead of waiting for that entire response to come in one big buffer, we could actually stream those results back to our clients in real time. So as one final bonus today in this video, let me go ahead and actually show you how we could get that working. Now, in order to show you this, I'm going to actually piggyback off of our last Edgy Edge function video about using OpenAI with Edge functions. And we're going to do a little bit of a modification there in order to actually support streaming. So here we have our project from the last video. If you'd like to follow along, just go ahead and first watch that video if you haven't already, and then pull up that project now. Now, the first thing we're going to need to change here is we're going to need to turn this create completion function into a streaming function. Now, if we look into the options on this function, we'll see that there is actually, in fact, a stream mode. And as you can see in the documents, this actually talks about how it uses server sent events in order to accomplish that. One would think that this is perfect for this situation. We should just be able to say stream true. Unfortunately, though, it turns out that there is currently a bug today with the completion JavaScript library from OpenAI, where even though this option does enable the stream, we actually have no mechanism to retrieve that response body as a stream. Hopefully this will be fixed in future versions, but all is not lost. Essentially, this create completion command is actually just wrapping a fetch request under the hood for us anyways. As you can see here, it's actually wrapping in an Axios request and response. So it's actually quite simple for us to just create this fetch request to their API ourselves. Let's go ahead and do that. So there we go. What did I just do here? Well, I've essentially removed our old completions function from the OpenAI library directly, because as we just chatted about, the streaming function unfortunately does not work with that library today. I took those options that we used to pass into that and put it into its own variable. I'm just calling completion config. Since we do have the benefits of types here with TypeScript, best practice will be to assign it to that same create completions request type that our old completions function expected. This prevents us from entering in any other incorrect values here by mistake. Everything else was just one-to-one copied over though. And then down here at the bottom, we're calling a simple fetch request. The fetch API is built right into Dino. So coming over here to the OpenAI documentation, you can see here, all that completions function was doing is calling this completions endpoint. And note this is a post request. First parameter is the URL for the endpoint, and second parameter is options we pass in. Expects this to be a post request. The headers, we are passing in JSON as a content type. And then we also need to authorize manual RSLs. Now, before, when we used the OpenAI library, they handled all that authorization logic for us under the hood. Now we just need to make sure we add that header ourselves. It is very straightforward though, just an authorization header of bearer type, space, and then our OpenAI key directly inserted right in there. And then finally, the body of our post request is going to be the contents of this completion config. Of course, we first need to stringify it as JSON in order to send that. Now, the last thing you might be wondering here is why are we returning the fetch directly here? Well, it turns out that Dino has made their APIs such as fetch and response actually integrate seamlessly with each other. So instead of returning a response here, we can actually just directly return the result from our fetch function as the return value for our entire Edge function itself, and it will go ahead and take that response body and stream that to our client on our behalf. Super handy. And then just to review, the strategy is the first one we were talking about earlier, which is the basic HTTP proxy, where we return the fetch function directly. Now, if you needed to manipulate that data before you return it, this HTTP proxy with transform would be where you want to go next, where you can actually pipe the response body through a transform stream, and then you can manipulate it however you like. So finally, let's test this guy out. We'll paste in our curl function from the last video. And as our query will once again say, what is Supabase, to see what GPT-3 will reply with. Let's go ahead and hit enter, and we should expect to see a streamed reply this time. Let's go. And there we have it, our streamed reply. Now that might have been hard to follow. If you look carefully here, each message here is actually a stringified JSON object where it returns a bunch of information, including the ID, the model, and a bunch of other things. The most interesting part here is the text field, where you can see as we scroll up through these, the text field actually changes a little bit here to have essentially different tokens or words responded one by one. So next steps with this would be on your client side, you would essentially be listening for the stream using something like an event source. And then as each message comes in, you would parse this JSON, take the text, and concatenate each text message with all the previous messages. That will give you that nice visual of each word popping in one by one. So that's it for today, guys. Hope you learned something new about Edge functions and streaming. Thanks so much for joining me today, and I hope to catch you on the next video.